Right, my dear children. Now in this chapter we will be discussing several questions related to the electricity lesson, but especially we are discussing about essay type questions in here. Right, let's move on with the first question. So we have to write down the correct answer in each of these questions. So the first question is given, write the international standard unit to measure the current. So to measure the current, the international standard unit that we use is called amperes, right? Amperes. So amperes is the unit that we use to measure electric current in a circuit. Amperes, right? Amperes, right? I'll mention the unit symbol. So in the second question, symbol is being asked. So amperes is our unit. So international standard unit to measure current is amperes. In the second one, mention the symbol of the unit. Symbol of the unit is capital A. Capital A. Write two subunits used to measure electric current. We need to mention two subunits to measure electric current. So there are two subunits. Number one, milliampere. Milliampere. Simple M, capital A. Milliampere. Number two, second one, microampere. Microampere. So microampere, this mu sign and A, microampere. Right. So milliampere and microampere are the two units, the subunits that we use to measure electric current. Especially these two units are used to measure very small amount of electric current. Ampere we use it to measure large electric current. Milliamperes and amperes to measure small electric currents. Next question. Convert 2.5 amperes into milliamperes. So what's the relationship between amperes and milliamperes, my dear children? If you take 1000 milliamperes, this is equal to exactly 1 ampere. Exactly 1 ampere. So you need to convert 2.5 amperes into milliamperes, right? Then in that case, we need to multiply 2.5 amperes by 1000. Because 1 is equal to 1000, you have to find out how much is 2.5. If 1 is equal to 1000, to find out 2.5, we need to multiply 2.5 by 1000. So our answer would be, we need to cut these zeros and we need to move the decimal point 1, 2, 3 units. So our answer would be 2500 milliamperes. This is the answer. 2500 milliamperes is the answer, right? So 2.5 amperes is equal to 2500 in milliamperes because 1 ampere is equal to 1000 of milliamperes, right? 1000 of milliamperes. So these are the answers for the first 4 questions, right? So we'll move on with the next one. So the next question, what is the most suitable instrument to measure current in a simple dry cell? Measure current, simple dry cell. So we need to write down the most suitable instrument to measure current in a simple dry cell. Simple dry cell means a triple size battery, a dry cell, a remote cell. To measure current in that kind of a dry cell, we can use the milliammeter, not the ammeter, but the milliammeter. It would be quite easy to get the readings if you use a milliampere, right? If you use a milliammeter. So it's wise to use a milliammeter when you are using just simple dry cells. So our answer would be milliammeter. Milliammeter. So milliammeter is the most appropriate instrument to measure electric current in a simple dry cell. Next one. Write reasons for your answer in the above. So our reason is because milliammeter is the instrument which is more sensitive for small currents, right? To measure larger currents, we use the ammeter, right? We conducted an activity also to show that using of milliammeter is quite easy to measure very smaller currents. Not the larger ones, but the smaller ones. So the reason is really simple. Our reason, we can write it like this. Because milliammeter is sensitive to very small currents. Very small currents. So why do we need to use the milliammeter? It's because milliammeter is sensitive to very small currents, right? So milliammeter is sensitive to very small currents. That's why we need to use the milliammeter thing in here. It's wise to use milliammeter. Using an ammeter is somewhat difficult, right? To take the readings, it would be somewhat tougher, right? So therefore, it's wise to use a milliammeter so that we can get our readings very clearly and accurately. So milliammeter is the instrument that we need to use when you are measuring very smaller currents, right? So in the next question, P and Q are two instruments that used to get measurements related to electricity. Now to get measurements related to electricity, P and Q instruments are being used here. So P and Q are not given in their standard symbols, okay, right? So P and Q are two instruments which has been connected to the circuit to get different types of readings, or to get different types of measurements related to electricity. So here, if you check the circuit diagram very well, we can see that bulb is directly connected. The bulb is directly connected with the Q instrument. Electrical charges going to flow through the bulb, through the Q, and it will come to the negative terminal of the dry cell. So here it's obvious to us that the connection between bulb and the Q instrument, this connection is a series connection. This is a series connection. Then the next one. If I am going to erase P and remove P from the system, even though I am going to remove it, this will work. The bulb will light up. It's because that the bulb and the Q unit is connected parallelly to the circuit with the instrument P. So P is showing a parallel connection. That's why even though I'm going to remove these things, there is no difference in the above circuit. Above circuit is working even though I'm going to remove the P instrument. So see, now you can check this thing very clearly, right? If I'm going to remove P, then there is no difference. Even though I'm going to remove P, the above system is going to work. Means that P and this system is having a parallel connection. So we can write this is a parallel connection. So now we need to identify the two instruments. What is the instrument that we connect series to a circuit to get relevant measurements related to electricity? What is that instrument? My dear children, it's the instrument that we use to measure the electric current. So definitely this should be an ammeter. So Q is an ammeter. Milliammeter is also correct. So I'll mention milliammeter as well. Milliammeter or ammeter, both the things are correct for Q, right? Because we connect ammeters or milliammeters in a series connection to a circuit to measure the electric current, right? Then the P. P is showing a parallel connection. My dear children, we connected a voltmeter. We connect voltmeters parallel to a circuit to measure the voltage. So this P instrument should be a voltmeter. So by using the connection method, we identified the two instruments P and Q separately, right? So the instrument which connected series connection in a circuit, that's the ammeter or the milliammeter. The instrument which has a parallel connection is the voltmeter, right? So voltmeter and ammeter can be directly identified by using their connection as well. Ammeter is always showing, or milliammeters are also always showing a series connection, while the voltmeters are showing a parallel connection. So by that way we have identified the P and Q instruments. So P is a voltmeter and Q is a ammeter or a milliammeter. Name the two connection methods of P and Q separately. Now you have to mention the connection types of P and Q separately. So I have here mentioned. So we'll write it down once again. P means the voltmeter, parallel connection. P means the voltmeter. Here you can observe it, P. showing a parallel connection. Then next one is Q. Q, here Q, you can observe it showing a series connection. So parallel connection and series connection. These are the two connection methods of P and Q. Right. Next one. What is the other instrument given by the symbol this? So, what is this symbol? This one. It's, my dear children, is the bulb. Right? To indicate a bulb, a normal torch bulb, not an LED, right? It's a normal torch bulb or else a normal bulb. To indicate a normal torch bulb, a normal bulb, we use this symbol, right? So, bulb. Right, my dear children? So, this symbol reflects the bulb or the simple torch bulb, right? Next one. A usual remote cell within brackets included the size of it, AAA size. So, a usual remote cell, AAA, is used to power up the circuit. How much is the voltage of it? Now, this is a simple remote cell, AAA size, normal cell, dry cell that we use to power up the circuit. So, the question is asking how much is the voltage of it. We have even measured these things and we recorded the observations. So, in a simple dry cell, in a simple remote cell, in a AAA size dry cell, the voltage is about 1.5 volts. So, 1.5 volts is the answer. Right. By removing Q from the circuit, a resistor is connected to the terminals of Q. Redraw the circuit diagram accordingly to show the new circuit. And now we are removing Q here, right? We are removing Q here. And instead of Q, Q is being replaced by a resistor. It's being replaced by a resistor. So we need to redraw the diagram, circuit diagram, to indicate the new circuit. Right. So take the slide somewhat up. This is my new circuit diagram. First of all, the dry cell. Then the bulb. So Q is going to be removed. Instead of Q, I am going to use a resistor. So the symbol for a resistor is like this. This is the symbol for a resistor. Or else you can use this symbol. I'll draw a separate figure here. You can use this symbol. This is also correct. Like this. Right. So now Q has been removed from the circuit. So we have to connect the P like this. P is still in the circuit like this. There is no difference in P. We are only removing Q from the circuit. So instead of Q, we have plug in a resistor. So this is the circuit symbol for a resistor. You can use either of these two figures. One you like. Okay. Both the figures are okay. Both the symbols are okay. We use this symbol to indicate the resistor, a permanent resistor, or else this symbol to indicate a permanent resistor. Right? You can use either of these two figures or symbols when you are representing a resistor. Right? Answer the questions using the given figures. So there are 4 figures given here. Right, my dear children? So in this question, see, you have to answer the given questions by using the diagrams given here. So there are 4 diagrams given, P, Q, R and S. There are 4 diagrams, P, Q, R and S. Right, let's identify first of all what are these instruments. P, a symbol is at the middle, plus and minus can be observed. So you know this is an ammeter. This is an ammeter. Or milliammeter. Second one, Q. Like the ammeter, capital V symbol can be observed. So that should be the voltmeter. Voltmeter. Right. So you can observe this one as the ammeter and this is the voltmeter. So the third one, R. What is R, my dear children? R is the dry cell. The longer terminal is the positive terminal, shorter terminal is the negative terminal, usually in a dry cell. So this is the circuit symbol for a dry cell. Then the fourth one, S. In the earlier question also, when I am drawing the circuit diagrams, I told you that for a permanent resistor, we use this symbol. So this is a permanent resistor. Right. So these are the P, Q, R and S instruments. See, ammeter or milliammeter, P, Q, voltmeter, R, the dry cell, then S, permanent resistor. Permanent resistor. Right, now let's see what are the questions given. Number 1. What is the instrument used to measure potential difference from above? Now we use the voltmeter to measure the potential difference. But if you write voltmeter like this in here, most of the times you won't be giving out the necessary marks for these things. What is the reason for it? Because the question is saying answer the questions using the given figures. So this figure voltmeter, we know that this is a voltmeter, but this instrument is being marked as Q. Right? So therefore our answer should be Q. Q should be definitely there. Q should be there. If the Q answer is not there, you won't be giving out necessary marks. So it's okay to write as voltmeter, but write it like this at least. Q, the voltmeter. This is more accurate. Right? If the questions are given like symbols in this type of a question, you have to answer the question. You have to answer the questions by using the symbols, right? It's okay to mention the real name, but mention the symbol first, then mention the real name. Don't mention only the real name. You have to first mention the symbol or the relevant letter, then after that you have to mention the real name of the instrument, right? So our answer would be we use Q or voltmeter to measure the potential difference, right? Second one, Name the instrument R and state how to identify positive and negative terminals of it. R is the dry cell. So our answer is dry cell. Dry cell. Or else battery. Dry cell, battery, or else a cell is also in simple. Right. All of these responses are correct. Then you have to write down how we can identify positive and negative terminal of the dry cell or the cell given in here. So my dear children, how to identify the positive and negative terminals in a dry cell? By using the circuit symbol. It's really simple. Now earlier also I told you that I have mentioned the positive and negative terminals in the dry cell by using that feature. So during a standard notation where we are going to use the positive and we are going to use the positive and negative terminals, right? In a dry cell, always the lengthier terminal is the positive terminal, longer terminal is the positive terminal, shorter terminal is the negative terminal. That's a standard notation. When you are representing a dry cell, one terminal is a lengthier terminal and one is a shorter terminal. Lengthier one is the positive terminal, shorter one is the negative terminal. By using that feature, we can directly identify the two terminals of a circuit symbol in a dry cell. So, how we can identify the positive and negative terminals? By using the icon, right? Or the length of the two terminals, we can identify the positive and negative terminals. So we can write longer terminal, it is the positive terminal, right? Longer terminal is the positive terminal. Then I'll use the black color to show the shorter terminal or the negative terminal. Shorter terminal, then that's the negative terminal, right? So R is the dry cell or the battery or the cell. Here we identify positive and negative terminals of R by using the longer terminal, that's the positive one, and the shorter terminal, that's the negative one. Here also you can observe it. See, shorter terminal negative, longer terminal positive. That's how to identify positive and negative terminals in a circuit diagram of a dry cell. Right. Next question. Name the instrument that can be used to control the current in a circuit. State the name of the instrument as well. To control the current in a circuit. So to control the current in a circuit, we have to use a resistor. So the resistor is given in here. The S instrument is a permanent resistor, right? So we can write the answer as the instrument that can be used to control the current in a circuit. It is the S instrument, which is called as the permanent resistor. Permanent resistor. Permanent resistor, right? S is the instrument which is called as the permanent resistor. Next one. If actual P instrument is given, how can you identify positive and negative terminals? If actual P instrument is given, P means ammeter. If actual ammeter is given to you, how can you identify the positive and negative terminals? So my dear children, it's really simple. I told you, usually when you take an ammeter or else a voltmeter, the positive terminal is indicated from the red color. Negative terminal is always indicated from the black color. So that's a special notation when you are naming positive and negative terminals in these instruments. Always we use the red color terminal to indicate a positive terminal, and we use the black color to indicate a negative terminal. So by using that feature, we can directly identify the two terminals in a ammeter. It's really easy. Just we need to take the two colors. So the positive terminal is the red color one, negative terminal is the black color one, right? Okay, so we can write the answer. If actually you are given with if actual instrument or else an actual ammeter is given, if an actual ammeter is given, this is how to identify the two terminals, positive and negative. So red color terminal, red color terminal, this is the positive terminal. Red color terminal is the positive terminal. Then the other one, black color terminal. Black color. That is the negative terminal. So this is how we can identify if you are given with a real or actual ammeter or else a voltmeter. Both the things we can use these features, right? There is a red color terminal and there is a black color terminal. The red color terminal is the positive terminal, black color terminal is the negative terminal. This is how to identify the two terminals in an ammeter, right? By using this color change, we can identify it. Right then. So we'll move on with the next question. Name the instrument which used to measure current. Mention the connection method as well. So to measure current, you know, we use the instrument called ammeter. So ammeter can be observed in here. This is the ammeter, right? So my dear children, we can write our answer. So the instrument which used to measure current is called the ammeter. I told you, if you are being asked to write down the answer, if the symbols are given, mention the symbol first or mention the letter first, then write down the actual name, okay? So here P is our answer, P, which is called as the ammeter or the milliammeter. Ammeter or milliammeter. Then you have to mention the connection method. To measure current in a circuit, the ammeter should be connected in a series connection, my dear children. Voltmeter should be in a parallel connection and the ammeter should be in a series connection to measure the current. So the second answer would be in a series connection. in a series connection. Right. The next question. Connect R with S and draw a circuit diagram. For the same circuit, connect P and Q to get relevant measurements of S. So we have to connect R with S. Means that we have to connect the dry cell to this permanent resistor. In a permanent resistor, there are no distinct plus and minus terminals. Right? In resistors, there are no such plus and minus terminals. You can connect these things to whatever the way you like. There is no distinct plus and minus terminals in a resistor. Right? So my dear children, we'll draw the figure, the circuit diagram. We have to connect R with S. So first of all, we'll take the permanent resistor and we'll connect it with the dry cell. Then for the same circuit, connect P and Q to get relevant measurements of S. This is S. This is R. Then we have to connect P and Q instruments to this circuit. So let's see once again what is P. So children, this is P, the ammeter. Ammeter is the P instrument. So we need to connect ammeter in a series connection. Means that the electric current should run through the ammeter and should pass through to the resistor. So if you have been asked to draw a setup like that, then it should be like this. Between the two terminals of resistor, we need to connect the ammeter like this. Don't forget about the plus and minus term. So this is minus, this is plus. In the ammeter, this terminal which runs to the positive terminal should be the positive. Here this one should be the negative terminal. Right. So we have connected R to the circuit and we have connected S to it, and once again ammeter, which is the P instrument, P. Then we have to connect the Q instrument. Q means the voltmeter. So we have to connect voltmeter to get the measurement of this S, or the permanent resistor in the circuit. So how to connect the voltmeter? It's really simple, my dear children. You need to plug in the voltmeter directly, right? You need to plug in the voltmeter directly like this, right? So this is the negative terminal, this is the positive terminal. Or else, now we are about to measure the potential difference of this resistor now. So if you want, you can connect the voltmeter like this way around also. From here to here, you can mention from here to here, you can mention it like this. This is also correct because we are measuring the voltage of S. Right. So we have to connect it to the two terminals of S like this. So we'll mark out the positive and negative terminal, the negative terminal, the positive terminal. Right? If you want, you can draw it like this way around also. This is also correct. Permanent resistor, ammeter, then the voltmeter like this. So this is R, this is S, the resistor, and this is P, this is Q, voltmeter. So this terminal is positive, this terminal is negative, this terminal is positive, this terminal is negative. This is negative. So both of these figures are correct. Okay, it's no problem. So this is the circuit diagram when you connect R with S and to get relevant measurements of S by using P and Q. Right. So let's move on with the next question then. Write two conditions that we need to consider when connecting voltmeter to a circuit. Two conditions that we need to follow when connecting a voltmeter to a circuit. So when you are connecting a voltmeter to a circuit, we need to remember the voltmeter should be connected in a parallel connection. The voltmeter should be in a parallel connection. Right? It should be in a parallel connection. That's the first and foremost case. Right? And the second one is that we have to connect positive and negative terminals of the voltmeter correctly to the circuit. Positive and negative terminals should be connected properly to the circuit. If you interchange those two, then your readings may get faulty. Right? Okay, so we'll write it down. First thing, it should be connected parallel. It should be connected parallel to the circuit. It should be connected parallel to the circuit. And the second one is positive and negative terminals should be connected properly. Right? So these are the two main facts that we need to follow when you are connecting a voltmeter. Right? First thing is that when you are connecting a voltmeter to a circuit, it should be connected in a parallel connection to the circuit. So it should be connected parallel to the circuit. Second one, the positive terminal and the negative terminals should be connected properly to the circuit. Right? So this is the second one. So these are the two main facts that we need to remember when you are connecting a voltmeter to a given circuit. Right. The next question. Write two conditions that we need to consider when connecting an ammeter to a circuit. So this is the voltmeter thing, no? So if you are being asked to connect an ammeter, when connecting an ammeter or during the connection of an ammeter, we have to follow out these two facts as well. But the specialty in here is that you know that voltmeter is connected parallelly. But if you take an ammeter, ammeter should be connected in a series connection. So that's the first and foremost fact when connecting an ammeter to a circuit. It should be connected in a series connection. Right? It should be connected in a series connection. That is the first fact. So we can write it should be connected in a series connection. So it should be connected in a series connection. This is the first and foremost, most important factor. And the second factor is, like in connecting voltmeter, we have to consider about the two terminals. So we have to connect the two terminals, plus and minus terminals, appropriately to the circuit. So the second is that positive and negative terminals should be connected properly. Should be connected properly. Right? So these are the two main facts that we need to follow when you are connecting an ammeter to a circuit. First fact is, it should be connected in a series connection. Second one, positive and negative terminals should be connected properly to the circuit. Right? So these are the important facts that you need to follow when you are connecting a voltmeter or else an ammeter to a circuit. We have to consider about the connection method, and we have to consider about the positive and negative terminals. Right? So these are the two main facts that we need to follow when we are connecting a voltmeter or else ammeter to a circuit. Right. So let's move on with the next question. In a certain instrument, this symbol mu A, this is mu A symbol was printed at the base. Name this instrument. There is a certain type of an instrument. Mu A is being printed on it. Right? So this symbol is microampere. This symbol is the microampere symbol. So if microampere symbol is printed on the base of this instrument, definitely this instrument should be a microammeter. Right? It should be a microammeter. That's why microampere symbol is being printed on the base of it. Right? So you can write the answer microammeter. Microammeter. This should be a microammeter because that's why this microampere unit is being printed on the base of this instrument. Usually we represent the unit that we use to measure electric current at the base of the ammeter. If it is a just ammeter, capital A. If it is a milliammeter, simple M and capital A. If it is a microammeter, then mu A. Right? So if mu A is given, then it is a microammeter. Right, next one. name the special use of this instrument. So we have to name the special use of this instrument. Why do we use these microammeters? What is the purpose of using microammeters? So we use microammeters in order to measure very small currents. To measure very small currents, we use these microammeters. So it's really simple, right? Answer for the question in this one is really simple. We use microammeter to measure very small currents, right? To measure very small current. Microammeter is used. Right. So the special use of this instrument is to measure very small currents. Microammeter is used. We use microammeter to measure very small currents. Right. Fifth question. Can it be used to get measurements of a lead acid accumulator? State the reasons for your answer. To get the readings in a lead acid accumulator, that's the heaviest battery that we can observe. These batteries are referred as the car batteries, somewhat heavier batteries. Heavier batteries means they are providing heavy amount of electric current. If it is providing heavy amount of electric current, large amount of an electric current, we can't use this microampere thing to measure electric current. So therefore, this microammeter cannot be used to get readings in a lead acid accumulator, my dear children. It's because that in a lead acid accumulator, very large amount of current is given. So microammeter scale will not be sensitive to get readings in a lead acid accumulator. At least we have to use a milliammeter, but milliammeter is also not enough. Usually if you take a lead acid accumulator, the ampere value, right, is about, actually in these, the current is given from ampere hours. Normally it's about 30 ampere hours. 30 ampere hours means that if the circuit is operated for a 1 hour time period, right, and if 30 ampere of a current is being drawn out, right, then we can use that certain circuit for a 1 hour of time. So usually the current is mentioned in lead acid accumulators by using ampere hours. Usually there are like 30 ampere hours, 60 ampere hours, 80 ampere hours and so on, right? So it's difficult to use these microammeter things when you are getting measurements related to lead acid accumulators. It's because that the scale microampere is not sensitive to large currents, right? So we can write the answer. The question is asking here, can it be used to get the measurements of a lead acid accumulator? So we can write, or we can mention the answer, no, no, we can't use it, right? So the reason is because microampere scale is not sensitive because microampere scale is not sensitive to measure large currents. This is the reason. Because microampere scale is not sensitive to measure large currents. We can't measure large amount of current by using microampere unit. To measure very smaller currents, we use microampere unit. Right then. Okay, then let's move on with the next question. We have to write down the given measurements using the standard symbols. By using the standard symbols, you have to write down these given measurements. So here the first one is given 10 amperes. You know that amperes are being used to measure electric current. Right? To measure electric current, we use the unit called amperes. For amperes, there is a special symbol. That symbol is capital A. So by using that standard symbol, we are going to write down the values of these things. So the first one is 10 amperes is equal to like this in standard symbols. Right? 10 amperes. Then the next one, 150 milliamperes. 150 milliamperes. So 150 milliamperes can be represented like this. 150 milliamperes, simple M, capital A, milliamperes. 150 milliamperes like this. Next one, 2300 microamperes. For the microampere thing, we use the symbol mu, mu and A. 2300 microamperes. This is mu. I told you about the mu thing, the symbol mu in the earlier chapters as well. Right? To indicate microamperes, we use this mu symbol. So 2300 microamperes. This thing 150 milliamperes. Here 10 amperes. Right? So these are the standard symbols. Standard symbols of the units given here. So we have discussed several questions related to the measurements related to electricity lesson in this chapter. So I hope that you took a sound knowledge about the questions related to electricity lesson. So in our next chapter also we'll be discussing somewhat different questions related with the lesson. Right? I'll meet you on the next chapter and we'll discuss about some different questions related with the measurements related to electricity lesson.